We will now determine the rate of change of theta when the balloon is 200 feet above the ground. And we are given this information that the hot air balloon comes back down at a rate of 15 feet per second. So first I'm going to convert this information into mathematical symbol. For that, let's look at this picture. So I have labeled the positions of the person as P, a balloon as P, and the ground is G. This is a right triangle, and the angle theta is the angle of elevation. And the distance between the person and the ground is 500 feet. And let's say that BG represents the height of the balloon at certain time. So h is the height of the balloon at certain time, and since the hot air balloon is coming back down at a rate of 15 feet per second, we know that the height is decreasing. So we can denote this by dh over dt. Since there is a change in the height, we write this as a dh over dt, and we put a negative 15 feet per second. Since the height is decreasing, it is negative 15. So we have converted this information into mathematical equation or using the derivatives. Now in the step 1, I'm going to write down the trigonometric ratio, that is tan theta. So tan theta equals the opposite side by adjacent side. That is when you use the Sokatova formula. So opposite side is BG and adjacent side is PG. Let's substitute the value of BG. At this time, it is 200 feet above the ground. So let me substitute 200 for BG, and for the PG, the person is at a distance of 500 feet. So this goes as 500. Now this is simplified to 2/5. So at that time, when the balloon is at 200 feet above the ground, we found the value of tan theta equals 2 by 5. Now in the step 2, we are going to do the derivative. So once again, I'm going to write down the tan theta, but this time I'm going to write down as a formula involving the height. So it is once again BG over PG, but now I'm going to substitute BG as H because the height is varying. We need to determine the rate of change of angle with respect to the height. So and then PG will be 500. So let's continue with this. Therefore, we have the equation tan theta equals H over 500. Now we are going to find the derivative both sides with respect to time. So I'm going to write down this as d by dt of tan theta. This I can move a little bit. And then similarly for this, I write down d by dt. So which means I'm basically finding the derivative on both sides with respect to time. Now we know that the derivative of tan theta is secant square theta, and we use the chain rule to find the derivative of theta. That is d by dt of theta will be d theta by dt. So this is the thing that we are going to find. So this gets multiplied with d theta over dt, and this is equal to, I can factor out the 1 by 500 and then find the derivative of h alone. And this, we know that this is equal to dh over dt. So I'm going to change this to dh over dt. So from this equation, we know this quantity, and we are actually trying to find out the d theta over dt. So let's substitute the dh over dt. Dh over dt is negative 15. So I'm going to substitute negative 15 for that. So this side, this will become 1 by 500 times of negative 15. This is secant square theta d theta over dt. To solve this equation for d theta over dt, we need to know this information. Let's see how we can find this information. Basically, we are going to find this d theta over dt. This is the rate of change of theta with respect to time. To find the value of secant square theta, we go back to the step 1 and use this information, that is tan theta equals 2 over 5. So I'm going to write down separately here. That is tan theta equals 2 over 5. Using this and as well as trigonometric identity, I'm going to find the value of secant square theta. We have this trigonometric, that is the Pythagorean trigonometric identity. 1 plus tan square theta equals secant square theta. So I'm going to substitute the value of tan theta equals 2 by 5 into this identity. So when I do that, I put 1 plus 2 by 5 quantity square equals secant square theta. So we can simplify this further. This gives 1 plus 2 by 5 square is 4 by 25 equals secant square theta. Therefore, we can solve for secant square theta. So when you add these two fractions, we get 29 by 25. So basically the value of secant square theta is 25 over 29, which I'm going to substitute into this equation. So it is 29 over 25. I replace the secant square theta as 29 over 25 multiplied with d theta over dt. This is equivalent to negative 15 over 500. Now we can easily solve for d theta over dt. We have to multiply by 25 and divide by 29. So let's do that. So therefore d theta over dt equals negative 15 by 500. We multiply by 25 and divide by 29. We plug these values into the calculator to find the uh, value of this d theta over dt. So basically d theta over dt is negative 0.02586. This unit of this angle is radians per second. So this is the answer for this question. That is, the angle is changing at a rate of 0.02586 radians per second.